Hello. And again, I'm back to work on my game engine. This is probably going to be the last live coding session I do for a while. When I last left off, I had finished up the batch rendering API for a basic batch rendering with my, for right now, pretty bare bones 2D renderer. Get batch. Oh, did I already get it? Okay, log, resolve issues, and language syntax. Yeah, okay, cool. So we're all set. So last time when I left off, I had got an API working for, or an API pretty rendered out for Renderer 2D, which is my 2D renderer. So we can now programmatically draw sprites and text, in addition to being able to load up sprites as sprite components in a scene file, which will be useful when I actually go to make some levels. And the next big goal is to get an editor going so that I can construct scenes using components with a GUI fashion. And there's a couple of other big things that the editor needs to be able to do as well. But there's one last thing I need to do before I start doing all the architecture work to make a editor compatible with the enterprise runtime, and that is frame buffers. So at present, let me go back to the Solution Explorer. At present, I've got most of the things I need to create a platform generic renderer available in the graphics API. So I've got stuff for loading font files, I've got stuff for loading texture files, I've got stuff for creating uniform buffers, I've got stuff for compiling shaders, and I've got basically all the makings with which to create a renderer without having to directly reference OpenGL or Metal or DirectX. So in the future, if and when I go to add support for other graphics APIs, I basically just do an implementation of the stuff in graphics.h. It's going to be a little bit more complicated than that because I'll have to worry about cross-compiling shaders, which is harder to make agnostic, but setting that aside for a moment, getting a implementation of my engine on Metal and DirectX shouldn't be amazingly difficult because of the way that I abstracted it. But there's one big thing I have yet to implement, and that is the Framebuffer API. So I did originally, like, I don't know, like a couple of months ago, when I kind of did the top-down design work of trying to figure out how I wanted my API to work. I did put in some blank methods that will serve as my Framebuffer API, but I just haven't implemented them yet. So a lot of the design work is done. It's just a matter of getting them working. So I guess we'll dive right in. The first one is the create Framebuffer call. So the way that it's going to work in this engine is that we'll take in a width and a height for a Framebuffer. So that might be the size of your screen. That might be, like, if you're doing like a pixel art game, that might be the size of your simulated screen. It might be the size of a texture that you want to render onto a surface, depending on what your need is. But this will take the width and the height in pixels, or in texels, I should say. And then it'll take an initializer list of this little struct, helper struct called Framebuffer attachment spec. I couldn't think of a cleaner way to do it. But basically, a Framebuffer attachment spec is a description of the settings that you need in your Framebuffer. So the first and the most important thing is the image format. So what style of image you need. And I've got a couple of basics in here that I know I'll probably need, but this is, expandable. Then there's the texture filter, which is the same texture filter modes that we'll have for regular textures. And then there's the samples, the number of samples you'll need, and then a Boolean to decide whether this will be a texture or a render buffer. So the difference being that a texture is formatted in such a way that it is easy to sample and use in your shaders. A render buffer is just in the raw, unprocessed, behind-the-scenes implementation dependent format, and you don't have to. If you're not having to use it in a shader or as a texture, then you just set this to false, and then you're good. You're good to go. You can use a depth buffer that performs a depth test without needing the need to convert it into a texture that you can sample later. I think I'm gonna rename these though. No need to put these underscores in front. And I think, yeah, I'm not referencing this anywhere yet anyway, so get that going. And I think I can do defaults for each of these as well. So I think by default I'll want to make textures. The samples, I'm still kind of new to frame buffers in general, so I'm not really clear on. I can't quite remember what samples does. It would be GL gen frame buffer. Let me see what that looks like. Oh, but it's actually GL. I'm trying to remember the call now. This will be important soon because we'll need to be using this code in a minute. Create frame buffers. Find frame buffer. There's like a buffer store method that actually takes and initializes the. Oh, here it is. GL frame buffer, texture 2D, and renderer 2D, I believe, or render buffer. I'm a little vague on this. I'm still kind of learning the API. Yeah. So here we go. I think the samples are specified here, aren't they? I'm just gonna straight up open up the GL tutorial. I was doing a little bit of research on this last night, and it seemed pretty straightforward. But this is still going to be my first implementation of frame buffers. GL frame buffers. Oh, they're not even going to be handled until anti-aliasing. Yeah, I'll put that on the back burner for now. So for the moment, I'm just going to go ahead and take the samples samples variable out of the frame buffer attachment spec, and we'll just specify the rest. I think I will not do default values. I think I will require that you specify each of these when you go to specify the frame buffer. But yeah, so the gist is that you pass it a initializer list of those to create frame buffer, and then it'll do the behind the scenes work of creating the frame buffer. So it'll call GL gen frame buffer, and then create the buffer store, whether that's a texture or a render buffer, and then it'll return a handle by which we can bind it using push and pop frame buffer. And I've elected to go for a frame buffer stack for reasons that'll probably become clear when I get to doing a rendering pipeline example. But the idea is that you're going to be, on a per game basis, assembling your own render pipeline. And you may run into a situation where you need to recursively render to smaller and smaller frame buffers. So a good example of that would be like if you were doing an implementation of like Portal 2's portal system, you may want to as a pre-render pre-rendering stage, render the scene through the portal to a frame buffer, and then call scene manager draw scene, and it'll render to that frame buffer, and then when you're done you pop it, and so on. But if you wanted to do like 3 or 4 levels deep, then what do? You gotta recursively go in and then go out. And so a frame buffer stack works pretty well for those kinds of situations, in my opinion. All right, so let's head to the blank slate of graphics create frame buffer, and let's get started. So I've got the OpenGL helpers header in here, so I can do my EPGL wrapper, and then we basically just need to do a GLGen frame buffers, and I think at the moment I'm just going to do one at a time. I don't see the need to extend this API to do more than one at a time. I think it might be overcomplicating things for now, but we do GLGen frame buffers, and then we just provide the count and then the address of the unsigned int to return to. And actually I think it's technically a GLU int. Whenever I'm using the API, I like to do the GL types, because there's a type def in GLAD that will always map this to the correct type. So just for clarity, just to make sure that people understand I'm using this as a OpenGL value, I just use the GLAD type defs. So in this case, we'll do frame buff handle, and then we pass in the one for one frame buffer, and then the address of frame buff handle. And what the hell? Let me go ahead and give that a proper spelling. Cool. And then we gotta deal with the data store. So once it's gen, we gotta bind it. We'll do read and write for the sake of getting the thing going. And then we got to do these guys. So if we're doing a texture attachment, which is specified by the bool, then we will need to, by bool I mean inside of the attachment spec, if we say make textures true, then we have to do a call to gen texture, bind texture, and all of that. And if we're doing a render buffer, if that's false, then we have a different line of attack. So we're going to need to start by going through all of the attachments, so all of the attachment specifications. So we'll do a range-based for loop, we'll do a for const frame buffer attachment spec by reference attachment in attachments, and then we will do if attachment dot make texture, then we will do the create texture logic, else we will do render buffer. And heading back to these calls. I'm just gonna this is simple enough code, but I'm gonna go ahead and just straight up copy and paste it for the sake of making this go quicker. So this is all going to be scoped, so we'll declare the texture handle in here. Then we got GLGen textures, we get the texture handle out of it, we bind it. Now, I'm on the fence a little bit about handling texture types, because like for now, 2D textures is really all I care about, but there might be a situation in which we need to render to a 3D texture. So I think what I'll do is I'll make this conditional upon in the Framebuffer attachment spec the image format. So like if I need to implement additional format types that are 3D, like I'll do a 3D style, like an enumeration case for 3D. But for now, I will just assume that it's going to be texture 2D. Though, yeah, that's fine. And then when we're going to be implementing the depth and stencil formats, those go separately. So for now, we'll do just GL texture 2D, and we'll go ahead and generate one. In the example, they specified this stuff for like just hard-coded values. In our case, we're going to do our own width and height from the parameters. And then this format is going to need to be specified from the image format. So I think, I'm trying to remember whether I've got, it's possible that I've got a conversion method already for this as part of the GL helpers header. I'm going to do a quick search to see if I've already done that. It doesn't look like it. So the idea is that I want to just be able to quickly get the GL version, the GL enum representing the buffer type from this class. And we're doing this all in a generic fashion, so that way I can simply swap out DirectX later on, or metal. So what we'll need to do is we'll need to go to GL helpers, and let's add a helper method for this. So we've got OGL type to shader data type. This will be something similar, but it'll be a GL enum instead. So the when we go to do GL text image 2D or GL text image 2D, this guy. Just checking my bases. The format and the internal format we need to get a return for. Which now I'm getting a little confused. So target level is the MIP, so that should be 0 by default. Internal format is an int, which specifies the number of color components in the texture. Must be one of the base. Okay, so if that's actually just a integer, heading back to the call, then how come they do GL RGB as the third argument here? Yeah, I don't know the answer to that. So in the example that they've cited for GL text image 2D, they're using, let's see what their documentation they link to. Internal format specifies the number of color components in the texture. What they're doing is they're passing GL RGB to that, but it's actually not, that's, not a number, that is a ID basically. It comes out into hex 1907. Which is not 3, if we check our math. So let me double check internal format. Okay, here we go. If the application wants to store the texture at a certain resolution or a certain format, you can request the resolution and format with internal format. It'll choose an internal representation that closely approximates what's requested by internal format, but may not match exactly. With the exception of red, green, blue, and red and blue alpha. Got it. Okay, so actually, no, it's not simply an integer, which is good. But now I need to confirm whether these are literally exactly the same as what you specify for the other parameter, which is format. Looks like there's some strong overlap there, at least. Going to do a quick side-by-side comparison. Here we go. So red, green, blue, blue, green, red, red integer. So some of these are in common, but the internal format may differ a little bit. So it sounds like I probably won't want to do a single lookup call, but taking a look at the texture image format, I can infer the internal format, the GL internal format, from the format. So like all of the information needed by internal format is technically encoded in here, given our use case. That's probably not exactly the case, but it probably will be for our engine, that if we are specifying GLRG, then the internal format will probably be an RG format. So yeah, I guess that calls for 2 lookup functions then, is the long answer. So we got the GL int OGL. Actually, there'll be image format to OGL. We'll say format and image format and internal format. Taking in the image format, and then a similar thing, but it's GL enum image format. Let me make this a little bit shorter. Image format to OGL. Getting a little bit wordy, but I think I'm okay with it in this case, given the number of things we're going to have to, number of different kinds of types we have to juggle. Cool. And I might as well make this inline, because it's essentially a direct call. So we'll do inline. Now what we'll do is we'll do a switch on format. Oh, would you look at that? It autofilled for me. I don't remember when that became a thing in Visual Studio, but it is welcome. So what we'll do is we'll return, in this case, GLRGB. I think just GLRGB is enough. I guess we're doing the internal format now, and so that's in Table 3, 1, 2, 3. Oh, these are the compressed. So any of these values really. So basically, for a RGB 8, I suppose if we're specifying 8, then I do want to use the sized version of this. So we'll do RGB 8 for the return value, and similar for these. And I think there's a 1-to-1 correlation to these internal format. RGB 16F. Yeah, it gives us the floating point 16 bit RGB there, and probably can do the same for the rest. And for the case of the depth buffer, we actually have to use a depth specific format for this. And it looks like we don't have a fixed size version of it, so we'll just do GL depth component for the internal type. And then if we're doing depth stencil, we'll use this guy. Oops. And then we need a stencil by itself. Come on. Or maybe we don't have that option. I'm still kind of new to stencil buffers as well. So what I'll do is I'll take just take that out of the running for the moment. And I'll do the same for this guy. Actually, since I am new to depth and stencil stuff, now, you know what, I'll leave it. I'll leave the depth formats in image format for the moment. And then through testing, we can confirm if I need to make any changes. So we got 3 basic color formats. There's obviously a lot more. I just picked these basic ones to get started with. If RGB8 is not good enough, then realistically I'll be using something that's floating point. So like if I wanted to do like HDR rendering or something, I would use a floating point. Cool. And in most cases where I'm using a depth buffer, I'll probably be doing this guy, because a stencil buffer will probably also be in use. Yeah, and then for the default value, I always do EP assert no entry, which is a little macro that just throws an assertion if it ever gets hit. So you put this in code paths you don't expect to hit. In this case, I'm running the presumption that whatever I specify for format is handled here, and if it's not, then I need to throw an assertion. Cool. And then let's do the helper for the other, for the image format, which has a little bit more detail. So we'll switch for format. Oh, it didn't fill in the case. Okay, switch on format. Cool. Awesome. Yeah, I didn't realize that this little snippet fills in automatically in Visual Studio. I probably would have if I read the instruction manual, but I never do that for some reason. All right. And then for these formats, I think these are very similar. I don't know if they're literally the same though. Image format. So underneath regular format, the following values are accepted. So in this case, we don't specify the width of the value, we just specify the format, red, green, blue. So that'll be the same for those. I'm not really clear on what these are for, but I'll put that on the back burner for the moment. And then specify the type of the pixel data, which is handled elsewhere. So where's depth? Here we go, depth component. And then stencil index and depth stencil, this last one. Cool. And now we've got helper functions for getting the OpenGL versions of things into this call. So this will be attachment dot format. We will wrap this in the I think it's image format to what's this first? Is the first one internal format? Yeah, the first one's in internal format, and then the second one is regular format, like so. And then do the same thing for this guy. Image format to OGL. Oops. Image format to OGL. Internal format. Wait. Image format. I'm getting it confused already. And then we pass the attachment dot format. Cool. And then this bit with GL unsigned byte, that would be what we specify for type. This will actually depend on the image, on the enterprise image format enumeration as well, because I'm using that enumeration to specify width and type. I think it's handy just to consolidate those into one piece of data. So I'll need to do another helper for this. So type is GL enum, I take it. Yeah, so let's go ahead and do another helper. And we'll do, this will be inline GL enum image format to OGL. I guess type is a little too generic, so I guess I don't know, data type might be enough. Yeah, let me say pixel data type. It's a little wordy, but if when I'm reviewing the code I decide that it's too unreadable, then I'll go and shorten it. Cool. And then we'll take the image format as the parameter. All right, and then we got to do a switch. And we'll do it on format. We'll do the EP assert no entry for the default, and then for these guys we'll do unsigned byte for RGB8. Then for 16 and 32, we'll do return GL float. I'm a little confused. I'm sure there's a float in here. Maybe there's not. Is there, do we still have to store floating points as bytes or something? These are basic questions that I don't think I want to be dealing with right now, but oh, there it is, GeoFloat. It was just hiding in between these. Yeah, okay. Yeah, that's what I was looking for. I don't think there's a version of that that's double. I think it's all just float. But yeah, I can just do like so. Cool. And depth 32 float. I think depth, while it is an image format type, I think that the data is still specified with the same types as before. So in this case, we're doing GeoFloat, and in this case, we're doing GL unsigned byte, I believe. Yeah, cool. All right, that should be good enough for now. And heading back to the Framebuffer API, instead of doing this, we'll now do image format to pixel data type. Dot format. Cool. And then I think, I want to say that's everything. I'm trying to remember. Width, height, border. Does border need anything? This value must be 0, yeah. So then why make it a, yeah, if it must be 0, why make it a parameter, but whatever. There's probably some C reason why you needed that. And then the last is data. Specifies a pointer to the image data in memory. And that's going to be null, but we're in C++ land, so we're going to use null pointer instead. Because this texture is going to be used as a receptacle for rendering, not as a source. So we're not initializing it with any data right now. Cool, cool, cool. Taking a look at this, I'm just going to shorten the attachment reference to the letter A. That might make things a little bit smaller. Do I want to put this on a second line? Yes, I think I do. And then width, height, OGL image format. Yeah, I can shorten these a little bit. Yeah, image format to OGL. Internal format. That sounds like that abbreviation looks like international. Whatever. I'll just leave it like this. This is probably as consolidated as I want it to be. But I'll break this across multiple lines, make it a little bit easier. To read. And then we are not initializing with data. Cool. All right, and just like that, we've got the texture going. Head back to the spot of the tutorial we're following. Here we go. We need to specify the filters now. Easy enough. We're doing texture 2D for all of this. This will depend upon a dot mag filter and min filter. Do I have a conversion helper for that already? I got the shader data type conversion, which, you know, that being just a switch case, that could probably be a a inline method as well. I won't bother changing it for the moment, but let me do let me do a conversion for this guy, which I believe is a GL enum, but I don't quite remember. Yeah, it's a GL enum is for the parameter type. Or no, it's GL, what am I doing? I'm not changing the parameter name, I'm changing the parameter value. So that's actually a GL int, it looks like. If I go to GL text parameter I, which is the one I'm using. Yeah, so GL int is what I need to convert to. This will be image format to OGL. To OGL what? I just had a brain fart. Forgot what I was doing. Yeah, so image format too. Oh, what am I doing? I'm not doing image format too. I'm doing the filter now. Filter mode to so texture filter is the name of the type. So text filter to OGL filter, and we'll take texture filter and color filter. Cool, and then we'll do a switch for filter. Right now, whenever I do one of these, I am actually getting the code ready for anisotropic filtering, even though I haven't got the GL extension going yet that adds anisotropic filtering. I'm just prepping the way for it. But for the rest of these, we'll do return GL nearest and GL linear. It gets a little more complicated than just these two values, because if you're doing like mip mapping, for example, you need to have the mip map filter. Which, now that I'm thinking about it, the Framebuffer may support mip mapping as well. The way that I've been handling mip mapping on regular textures is that it'll automatically generate mip maps if your texture is a power of 2. So for non-power of 2 textures, you won't bother to do mip mapping, but yeah, you know what? I'm not gonna support mip mapping in Framebuffer textures quite yet, because all of the main use cases I have for Framebuffer textures is stuff that's like resolution dependent anyway, so like you're already picking the resolution that you'll display at, probably. The only exception that I can think of would be like maybe if you wanted to do like in like Mario Kart 64, where you've got the Jumbotron in the background and it just takes and displays the displays your view in the Framebuffer. But you know what? I don't think that counts either, because if you're doing that, then prior to rendering the quad, you will already know its apparent size and screen space. So you'll have the correct resolution texture to begin with. Yeah, so I'm not going to bother with mip mapping here. Cool. And then in here we can do text filter to OGL filter, a dot min filter, and then we'll do text filter to OGL filter, a dot mag filter, like so. Cool. And now we've set the minification and magnification. I don't care about generating mip maps for Framebuffer textures. Is there anything else I'm forgetting about? I think that's probably it for creating the texture. Just got to unbind it. Oh yeah, the most important part is that we got to actually get it bound to the frame buffer that we generated. So let's do that. GL frame buffer texture 2D. We're binding it to the currently bound frame buffer. Which attachment we use is going to need to be specified procedurally. We'll take care of that in a minute. GL texture 2D, which is the case for all the textures that we support for the moment. Texture, using the same name textures, so that's fine. And then 0 for, what is that, MIP level. Yeah, the mip level of the texture to attach, which is always going to be 0 in this case. So yeah, for the attachment that we select, that's going to depend on a few things. We're going to need to keep a running tally of how many color attachments we've got going. So we'll say int num of color attachments equals 0. And then we'll have to increment each color attachment value that we use depending on which color attachment we're on. Now, in addition to that, we also need to, instead of using color attachment at all, we'll need to use the depth or stencil attachment for those attachment types. So what we're going to need to do is we're going to need to do if a dot format. So we're going to need to do a condition on whether the format is a depth type or not. So what we need to do is we'll need to do image format depth, or if we do the same thing, but depth stencil, then we don't treat it as a color attachment. Else, all of the other formats will be color attachment types. So let's put this one on the back burner for the moment. We'll do if. What we'll need to do is we'll need to do a procedural way to increment from here. Now, I'm going to quickly do a check. All of these values are contiguous. So what this means is that I can do GL color attachment plus the number of color attachments that we've specified so far, and it will attach each sequentially because the value of GL color attachment 1 is 1 after GL color attachment 0. So that should be pretty straightforward. We'll do num of color attachments. GL texture 2D, yeah, perfect. And then we'll do, for the depth attachment, we'll do GL, oh, I forgot what attachments. Here we go. GL color attachment I, so we get depth attachment or depth stencil attachment. So what I could do, because actually these have to be separate types, I'm just going to do this as another switch and do this as a default case. Switch data format, and then we'll do case image format depth_d, and then case image format. Boom. All right, and then we can do a version of this for each of these. And then the default case will be for colors. Yeah, I think that works fine. So in this case, we'll be doing GL depth attachment, and then for depth stencil attachment, we'll use this guy. Boop. And I think that's it for the buffer stuff. We just need to wrap up. Yeah, good. Yeah, so that's that. Then let's do the delete stuff, and then I'll come back to this guy and do the render buffer version. Cool. So we got the create frame buffer. Oh, I should probably unbind as well. Frame buffer, GL frame buffer. I think GL bind frame buffer. Yeah, GL bind frame buffer. And this will be GL frame buffers, and then 0. And the purpose of this call is to get us back to the default frame buffer. And actually, after we're out of the loop, I'll need to also unbind the texture. Cool. Now that I'm looking at this code, I'm wondering whether this will conflict with my current textures system. The reason why I say that is because I have a system going where when you go to bind a texture using the graphics bind texture call, it will automatically handle loading up a different texture slot and then binding a texture to it. Because you kind of have to bind a texture to a slot in order to operate on it with GL bind texture and set its parameters and stuff. I'm wondering if this will be a problem for frame buffer creation. Now that I'm thinking it through, I don't think that'll be a problem. Because when you go to create the frame buffer, you are doing that as an initialization call for some system. So at any point where it makes sense to create a frame buffer, the textures that are already bound won't be in use anyway. Right? Oh, but you know what? The way that this will cause a problem is the fact that we don't bind a texture to a slot every frame if we don't have to. So what this might cause, the way that this might pose a problem is that we might fail to rebind the correct texture to that slot. So the way that this normally works is that when you go to call bind texture, we first check to see whether the texture is bound to a slot. And we do that with some internal tracking on this CPP file. And if it is bound, then we just return right then. Well, actually, we don't return right then. We then make sure that the uniform refers to that texture, the sampler to the uniform or whatever, and then we return. But we don't actually call bind to texture. We just let it be. So where this could be a problem would be that whatever texture slot we've bound last, after we've done the render, we go to, like, let's say in between one scene and the next, you create a frame buffer. That frame buffer would substitute the bound texture for that slot and then not set it back. It would leave the texture unbound. So I'm going to need to consider how to make that safe. So I guess what I'll need a way to look up and rebind the texture that's already in that slot. That would probably be the simplest way to handle it. But because this involves OpenGL code, it means that I'll probably need to handle this as an extern so that I'm not having to pollute my generic headers with this stuff. So we've got current slot of texture, so we can look up the texture slot if there is one for the texture. Do we store I guess that's the only way in which we store the slots. We associate a texture handle with a slot number. And if it's -1, then it's not assigned. So I'm having to do the reverse. I have a slot that I want to look up and rebind. So yeah, I'm kind of unsure how to handle this, because I'm also going to need to know which slot is currently assigned. So when we go to call, what is it? Underneath GL bind texture, when we actually go to invoke GL active texture, I need to actually keep track now of which texture is the active texture. I wonder if I could just look it up in OpenGL, because that would make things a lot easier. Okay, so GL get integer might give us a way to do this. Data returns a single value indicating the active multi-texture unit. The initial value is GL texture 0. So we have a way to look up which slot is in use. Now I want to know if we can surely of the texture in the slot for two reasons. First is that that I don't think that there's an API call that will get us the OpenGL name for the texture handle. But second is that texture handles are platform generic in my API, so it might mean something different on DirectX, so it's not acceptable to just, yeah. So I've got a way to look up the active texture. But then I still need to ask the graphics API which texture is bound. All right, so I think I'm just gonna have to bite the bullet and add an additional set of tracking. So we'll do an SD map. Well, not SD map. Let's do an array where the dimension is the maximum number of slots. Oh, you know what? Texture in slot. Oh, I've got a way. I've already got. Oh, okay, cool. So past Michael did something cool and already laid the groundwork for this. So it turns out that I'm actually already tracking in graphics.h. texture in slot. So this is a dynamically allocated array. That is the size of the number of slots supported by the implementation. But I have a sneaking suspicion I might not have used it anywhere. I have not. I'm not. Oh no, here it is. It just took a second for the search results to come in. So we've got the declaration, we've got the initialization, the deletion in the cleanup method, texture in slot, unbind texture. So when we unbind it, we deinitialize it. And we do set texture in slot when we go to bind. So actually this is already set up for us. I just forgot that I did it because it was forever ago. So what we'll do is go back to the code we were working on. Which was down here. Instead of binding back to 0, we can actually do graphics. Well, actually we're already in the graphics API, so I can just do texture in slot and then provide the active slot. But now that I'm thinking about it, that's a problem of its own because I need to know what slot it is. I could use the OpenGL API to get that, but why should I have to do that? What I'm going to do instead is I'm going to provide a way to look up the active slot if I haven't already. Max texture slots, texture and select, stop and call, no. Current slot texture. So I do have a variable called last bound texture slot. But I'm not. Oh, am I holding on to that value? Hang on a moment. You know, it looks like I've got a bit of a naming conflict here. I've got a graphics last bound texture slot, but then it looks like we've also got a declaration somewhere else. Hang on a moment. Int I equals last bound texture slot. So last bound texture slot appears to be a valid tracker for what I'm looking for. The thing I'm confused about, though, is that I thought I saw, maybe my eyes are just deceiving me a little bit, but I thought I had seen oh, maybe not. I thought I saw that there was a declaration again somewhere else. Maybe not. Well, whatever. This appears to be what I need, last bound texture slot, so I can just plug that in there. And that should be it. So basically what we did is without regard for which texture is in the slot. Oh, hi, Nobi. How's it going? I'm just doing a quick little bit of work before Thanksgiving. Yeah, so I'm keeping track of the texture slot information already. So once I use that slot to set up the attachment texture, I then rebind the correct texture. So that way it'll continue to be used when I bind regular textures. Cool. How's your day going today, Nobi? It's cool if you just wanted to pop by while I was online. I think this is all I need. I am brand new to this API, so I'm having to bang rocks together a little bit. Yeah, going good. I was working late, so yeah, slept in today. Yeah, that's good. Today's a good day to sleep in. Do you have to, are you, I forget, are you in the States? Or are you elsewhere? In the UK now. Gotcha. Do you, so living in the UK, then do you still celebrate Thanksgiving, like remotely or something like that with your folks in the States? Gotcha. Yeah. I suppose that it's not a very common thing to have work off in other countries for Thanksgiving. But yeah, I'm glad that you're at least going to be doing something. Or you usually do something, but you're not going to be doing something this year. I don't have to delete the attachments one by one. Not yet. I don't have plans. Yeah. Well, I try to cook myself and remind myself of home. Yeah. Yeah. Something to remind you of home and then call them. Yeah. That's nice. But yeah, it's not too late to get something. I suppose you can literally go shopping tomorrow and pick up stuff. I had to do all of my shopping today because today's the last day that the stores are open. I think that's probably all I need. Let me make sure that compiles. Any second now. I wonder why this is taking so long to compile. Are we building a whole bunch of stuff that I don't need? Shaders.cpp got some warnings. Huh. Actually, I might not have built some of the stuff that I did on Mac OS, so maybe that's why it's taking so long. Anyway, speaking of going to lurk because I had dinner. Yeah, thanks for popping in. Thanks for the lurk. Go have some dinner. Take it easy. I'm probably only gonna be on here for like another 30 to 40 minutes. We'll see. But take care. Okay, so it's not broken. I didn't break anything. That's good. But I feel like I'm overlooking something, so I'm gonna just Google a question. Do you have to delete Framebuffer attachments directly? There we go. Do you delete Framebuffer? Does a delete texture attach to this Framebuffer? I would have thought you'd have to release each texture that you've created as well. There should be a delete call for every create call. Well, you say I would have thought. So is that yes or no? Let me look at the OpenGL wiki. It kind of seems like the attachment needs to be deleted, but that if that's the truth, then it is sorely missing from this tutorial. I mean, I guess for the sake of this tutorial, it doesn't really matter because because this is for this simple example, they're just gonna close the OpenGL context at the end. But they mentioned deleting the Framebuffer object, but not deleting the texture. Which is so I'm not getting a clear answer either way from Googling it, at least not in the 5 seconds I took to do it. So I'm just going to go ahead and presume that I have to delete the texture attachment. So let's get started on that. I also need to keep track of the texture attachments so that way I can provide them back to whichever rendering system using the get color texture and get depth texture APIs. So let's implement that. I'll just do a static std. Yeah, I guess we'll need to do a map for frame buffer handles. Am I in the, yeah, frame buffer. It's occurring to me that frame buffer handle, yeah, it's a class member still. I'm not sure if I'm going to keep it that way. But we are associating the frame buffer handle with a list of textures, I suppose. So I guess the simplest way to do that would be an std vector of graphics texture handles. And then this will be the color attached textures. Or I don't know if that's a great name for it. We'll do something similar for the, instead of the color attached textures, for the depth buffer. I'm not bothering with the stencil buffer quite yet. Yeah, I'm going to do texture attachment. Be a little clearer with the names. So basically, a frame buffer can have up to one depth texture attachment and a variable number of color textures. Though I suppose this doesn't have to be a vector. I could make this an array. Because it's going to be at most 32, but it'll depend on the platform. Oh, that's actually something I hadn't thought about until this moment. I probably need a way. I probably need a way to check how many attachments the platform supports. I'm not clear on whether they all support 32. Yeah, so I'm going to need to pull some information from OpenGL at launch time, because there's a maximum width and height for a frame buffer, and just for safety, I want to make sure that nobody tries to do ridiculously sized frame buffers that won't fit. I'll deal with that in a minute. For now, I'll just do vectors. It's possible I could replace this with an std array, I think, for the max, but actually no, I couldn't, because the max is not even specified here. I don't know. I'll deal with this later. I'll just get started with the vectors and optimize later if I need. So now that we are creating the texture, we need to push it back. So this will be index aligned. So the first that we push into the color texture attachments will be the color attachment 0, and so on and so forth. Basically, the attachment list that you provide when you create a frame buffer, it is ordered, going from first to last. So we'll do color texture attachments at a dot. Actually, it would be at texture dot pushback. It would be pushing back the. Wait, what am I doing? Frame buffer handle. I need the frame buffer handle, which is this guy. Dot pushback and push back the texture. And then this will allow me to later on look it up. Index aligned. And then I'll need to do something similar for these guys. So instead of color, we'll do depth. And there's going to need to be a little bit of a check here. So for starters, we don't push back. In this case, we just say equals texture. But I also need to confirm that we're not trying to do more than one depth attachment. So we'll say if the check for a duplicate depth attachment actually probably should be earlier, so that we're catching it before we even go to generate the texture. So what we'll need to do a tracker. I'll just do bool processed depth attachment equals false, and then prior, like outside of the condition of whether we're making a texture, we're going to say switch for a dot format. This is swiftly getting pretty messy, because I've also got switches for a dot format in here, but whatever. Let me do, instead of doing a switch, I'll do if a dot format equals image format depth 32, or a dot format equals image format depth stencil. So as I introduce depth formats, I'll extend this if. Then I'll do the check for if processed depth attachment. Then we will issue a warning and move on. So we'll do graphics create Framebuffer. And then I don't think that there's any other details I want to specify with the warning. I think that's probably enough information. Maybe I'll do an EP debug break, so that if somebody runs into the situation, they'll immediately be able to just inspect and see where the problem is. And then I'll do a continue and move on to the next Framebuffer attachment. Else, we'll say processed depth attachment equals true. And then inside the loop, we will be able to process and create the texture if we need it, or the render buffer if we choose to do a render buffer attachment. So, probably good. Down here, then, we can count on this being the only depth attachment, because if it wasn't, we'd have continued already. Good. And now we are tracking the depth and the color attachments. So what we can do now is when we go to delete the frame buffer, prior to the GL delete frame buffer call, which I should wrap in my error catching wrapper before I forget, I can do a for loop going through the depth and the color attachments. Actually, I don't even need to do a loop on depth attachment, because that's just, there's only ever one. consts and delete textures. The number and then the pointer to an array of texture handles. So in this case, we just need to do 1 and then the address of depth texture attachments at FB. I believe that's how that'll work. Yeah, because that's a map associating the frame buffer handle with the texture handle. Now, if there is not a texture there, so delete texture silently ignores zeros and names that do not correspond to existing textures, then yeah, I don't even need to do the check. That's fine. But what if you don't attach a texture? That should be fine as well, because what will happen is that if we haven't already specified a texture attachment or depth texture attachment, then what will happen is this access operator will create the element initialized to 0, and we can pass that to delete textures anyway, and it'll be fine. Cool. So now we got to do the for loop for the color texture attachments. So we'll do and I can't quite remember the type that we got in there. Yeah, that's right. We're using a vector of texture handles right now. So we'll do for std or const std vector of type graphics texture handle by reference text. Does that work? No syllable conversion from oh right, we're not. Yeah, we can just iterate through the textures themselves. So what we'll do is we'll do const reference texture handle from each one of the elements of the vector stored at. Yeah, my brain's not running on a full tank of gas right now. Text. So at this point, we just need to call delete texture on any textures we find there. So this will be color texture attachments. We'll do at. Oh yeah, what am I doing? I would just do the address of text, right? Actually, I would need to do the address of text, because this is expecting an array. Right? Maybe not. Not actually clear on what the problem is. Looking at the thanks for the follow, King's Roar. I didn't see that pop in when it happened. So if you did that forever ago and I just missed it, thank you. Oh, I'm missing a closing brace. That's all it was. So delete texture for any textures that are bound to, or any color textures attached to the frame buffer, then do for any. Cool. All right, that's done. And then underneath the get color texture, we're just going to need to look up and return the texture handle. So first thing we're going to want to do is we're going to want to do if color texture handle or color texture attachments dot count frame buffer, and this will return 0 if we haven't loaded the frame buffer, and 1 if we have. So if we haven't added the frame buffer yet, then I'll do ep warn to let the developer know, hey, you are trying to use a texture attached to a frame buffer you didn't create. Let's say frame buffer handle does not exist. And it's not, I don't know if it's really helpful to provide the frame buffer handle itself, because that's just an integer. So what I'll do is I'll do a debug break, like so, and then return 0. So that it'll at least break on the line where there's a problem, and then the developer can inspect and say, like, go up higher in the call stack and figure out why they are calling get color texture on a frame buffer that doesn't exist. But if it does exist, then we need to access the color buffer and return it if it exists. And this is going to be a little tricky, because I'm just now realizing that if we were to do a render buffer instead of doing a texture attachment, then it might not be a valid texture handle. What I think I'm going to do is that when I get render buffers set up, what they'll do is they'll insert a 0 into the color texture attachments, so that way its vector remains index aligned. But you can still tell that a entry is not a texture, but it's a render buffer. So what we'll do here, now that we confirm that we have the FB, or the frame buffer, what we'll do is we'll do if color texture attachments at FB dot size is going to be greater than number. Else we'll do another warning. And then I'll provide the number as part of the call. So frame buffer does not contain blank texture attachments, providing, actually that's not quite correct. Does not contain color attachment with index, like so. I'll put those in single quotes for pretty formatting reasons. And that, I'll do the same thing here. I'll do a break and a return 0. And then, assuming that we've got the attachment to sample, we need to do one more check, and that's going to be if color texture attachments at FB at number equals or is not equal to 0. So 0 will be the null texture handle. So if it's at 0, then the attachment exists, but it's a render buffer. So we can't get the color texture from it because it's not associated with the texture. So we'll do a similar warning. Oops. Graphics, Framebuffer, color attachment. Is a render buffer. What I'll say is a texture. And then finally, after doing all that error checking, we will finally just return the value, like so. All right, so a fair amount of bounds checking when we do a get color texture. We're going to do something similar for get depth texture, but it's going to be simpler because it's not itself an array. It is just you either have it or you don't. So the outer bounds check needs to persist, where we check to see whether the frame buffer even was loaded. The second check, though, can go away because we don't have to check how many attachments there are. Well, actually, hang on, that's not exactly correct. We still need to do a check, but it's not the same one. What instead we need to do is we need to do a check for whether it equals something. So depth texture attachments. So what we would do is, oh, that's interesting. I'm just realizing a consequence of the way that I've implemented this, which is that if we aren't attaching a depth texture, okay, so what I'll do is that when I go to do render buffer attachments, I will do the same thing that I'm planning to do for textures, which is that if it's a render buffer and not a texture, I will still put in a value into the depth texture attachments, but that value will be 0. So this will check to see whether we've loaded it. Now I need to check whether it is non-zero, which actually means that, yeah, we can get rid of this outer check and just do it as the inner check. So instead of this, we've got this. We're checking whether depth texture attachment at FB is not equal to 0, because if it is equal to 0, then we will be looking at a render buffer. Cool. And that should be enough. Get depth texture, we check whether the frame buffer was loaded, then we check to see whether there's actually maybe another hole with this logic that I'm realizing now, because if I don't attach a depth texture, so there's 3 options: either attach a texture, or I attach a buffer, or I don't attach anything. If I don't attach anything, then this will still be 0. So I think instead of enforcing that a value get pushed in there, I'm going to need to change this error message. So frame buffer handle does not exist or does not have a depth attachment. And that'll cover the bases. But yeah, that should be good. Depth texture. If it's equal to 0, then it's not a texture. If it's not equal to 0, then it's fine and we can return it. Good. All right. Let's make sure that compiles real quick. Um, Good. All right. And taking a look then at the rest. For the moment, I'm going to leave these things unimplemented. Basically, I just need to do more setters and getters. So when I go to create it, I'll store it, and then I can return the values from here. And I think I'm going to skip to push and pop for the frame buffer, so that you can actually use the frame buffer that you create. In order to manage a stack, though, I actually need to create a stack. I actually think I do like doing std stack for these. I've only done it a couple of times, but I like how crystal clear the type makes the code. It's like it's a stack. Obviously, it's last in, first out when you're reading through the code. I'm just trying to remember exactly the correct way to use it. I think you literally just pass in the type. Yeah, and the second is the inner container, which by default is a double-ended queue, which is exactly what we want. So in this case, we'll do a stack of graphics frame buffer handles, and we'll call it FB stack. And this is basically just going to be the current list of frame buffers. So when we go to push, we add to the top of that, and we bind it. And when we pop, we remove the topmost element and bind the second to topmost element. So FB stack dot push FB, and then we want to bind the frame buffer, which I think is literally as simple as calling GL bind or GL bind frame buffer. Let's refer back to the tutorial on this. Yeah, GL bind frame buffer, like so. And for our purposes, I'm not going to do any API implementation that allows you to do read and write to two separate frame buffers. I don't see the value of that right now. Maybe my tune will change later, but for the moment I'll just do EP GL bind frame buffer, and then we provide GL frame buffer to specify that we're just doing read and write, and then we need to provide the frame buffer handle, which in this case there's a one-to-one correlation between my engine's frame buffer handles and the actual name provided by OpenGL. They're both unsigned integers, so I literally just directly use it. So I can actually just call GL bind frame buffer on the exact value that we provide, even though in DirectX or Metal this might be a proprietary value. And that's that. And then if we go to pop, we just go FB stack dot pop, boop, and then we will do EP GL bind frame buffer on GL frame buffer, and it'll be FB stack dot top, like so. Cool. Simple, simple, simple. All right. So I guess at this point we've got enough stuff together to perform a test. So the first thing I'm going to do is I'm going to take and create a frame buffer in my testing code, graphics, create frame buffer. We'll give it a width of the screen. So we'll do, I think right now I'm doing 720p, so we'll do 1080 by, wait, I think it's 1280 by 720. Is 720 resolution? I can't quite remember, but I guess it doesn't really matter for this case. And then I need to do the frame buffer attachments, which is an initializer list. So for this, we will need to initialize a list, which I believe is going back to the header. Frame buffer attachment spec, that's right. So that's going to be format, min filter, mag filter, and then whether we're making it as a texture. So we'll do image format, RGB8 for the moment. Then min filter, I'll just do text filter. I'll just do nearest for the moment. Nearest. And then true, because we want this to be a texture attachment. And now I will do a depth texture. So we'll do depth 32F, nearest, and true. Okay. So this should create us a frame buffer. I will need to hold on to the handle, frame buffer handle. Like so. And then store it here, fb equals so on. And then when I go to draw, I can actually do graphics push frame buffer, and we'll push FB, and then I will pop FB down here. Pop frame buffer. First of all, we won't crash if it works correctly, but then secondly, it will render to the off-screen frame buffer, so we shouldn't see anything on the screen anymore. Let's see if that does what it should. Okay, we got an insertion. Let's take a look. Back called on an empty deck. So there's something up with the stack. Retry. Let me take a look at how we've got a problem on the stack. Pop frame buffer is being called on an empty stack. That's interesting because it suggests that we didn't successfully push the frame buffer. Let's go back to the state code. Got pop, push. Yeah, so I guess we're gonna have to start and stop again. I'm putting a breakpoint on the push call because that should be leaving FB stack with a size of 1. Yeah. Okay, then we step out. Let's step over all this drawing code. And then we finally get to pop frame buffer. Let's step into it. FB stack is still size 1. If I step over it, oh, I'm an idiot. I'm popping it before I try to access the last element. All right, that was genuinely my bad. So let's recompile and confirm that this is working. Okay, so we're not crashing anymore, but we're also still rendering to the default frame buffer, which is not what I expected. When we went to push the frame buffer, what should have happened was it should have supplanted the default frame buffer. which might tell me that the frame buffer that we're getting when we create the frame buffer up here, that might mean that I'm getting a return value of 0, meaning that it didn't create correctly. Let's take a look. If it was a frame value of 0, then when we go to push, it'll push a frame buffer 0 on top. And then 0 is what you do when you're going to the default frame buffer anyway. So let's take a look. So we got gen frame buffers. We're passing it to frame buffer handle. Now that we've done it, we've got a value of 1. So we know that the gen frame buffer is getting a name correctly from OpenGL. Then we go to bind it. So it should be the currently bound frame buffer. We're going through the attachments list, which the attachments include format RGB 8, nearest sampling on minification and magnification filter. And then we're also doing a depth attachment, which is depth 32F is the format. So stepping over this for a moment. So we're making a texture, gen textures, yep, good. Let me step to the end here. So we get to the end, texture and slot, at last bound texture slot is currently 0 because we haven't bound any textures yet, which is good. Then we have GL bind back to 0. So at this point, we should have the frame buffer handle so we got depth texture attachment and color texture attachments pushed back. And if we take a look at their contents, we do have values. So 5 is the texture handle for the RGB attachment, and 6 is the texture attachment for the depth, which makes sense because we're creating the color attachment first because it's the first thing that I specified, and then we're doing the depth buffer immediately afterwards. So the depth texture immediately afterwards. So those should be textures n and then n+1, which adds up here. So, oh, okay, I was just being a dingus. So I forgot to return the frame buffer handle. That's the only problem. When I wrote the default function, I said return 0 just so it would compile, and I forgot to update that at the end. So my bad again. All right, here we go. I suppose bugs are pretty much always, quote unquote, my bad, right? Because that's how bugs work. And perfect, look at that. So, I mean, it's a black screen, but what this means is that we have bound a frame buffer and we're drawing to the off-screen buffer. So now we have the game being rendered to an off-screen buffer. That is cool. What we're gonna wanna do now though, is we're gonna want to render the contents of that buffer back to the default buffer using a quad. So I can use the renderer 2D API for this. So let's head back to the dev state. So now that we've done that, we've created the buffer, we've pushed it to the stack, we've drawn the simple little scene to it. Now I go to pop the frame buffer. We're back to the bottom of the stack. We're back to using the default frame buffer. At this point, we need to draw a quad. So I think I can just do renderer 2D. Technically, I got to do begin batch and end batch, even though I'm only drawing the one quad. But we'll do begin batch and end batch, then we'll do renderer 2D, draw sprite. The texture handle is going to be graphics get what is it? Get color texture. We'll get the color texture from the frame buffer handle. We've only got the one attachment, so int is going to be 0. And then we need to provide the UV sampling points, which in this case it's going to be 0 on the left, 1 on the right, 0 on the bottom, 1 on the right. And then we set the position of the sprite. So this is going to be dead center of the screen. So like at this point we're doing, we've popped the camera transform, so now we're in unit space, so it's -1 to 1, -1 to 1. So what we'll do is we'll just say position at GLM vec 3, 0, and then we'll do rotation of 0 as well, which is GLM vec or quat 1, 0, oops, 0, 0. I'm not sure if there's an easier way to do a non-rotated quaternion besides just spelling it out like that. And then we need to do the scale. And in this case, the scale will be GLM back to 2, I said. The scale will be literally 1, right? No, actually the scale would be 2. I hadn't thought about that until just this moment. The reason why it's 2 and not 1 is because the size of the quad is 1 by 1, but when it's about the center, that means that the left edge is at -0.5x, and then the right edge is at 0.5x. I need it to fill -1 to 1, so I'm actually going to be doing a scale of 2, and that should be enough. So I guess we'll see whether we start to see stuff on the screen again. It would be great if this worked first try. Okay, we got a problem. EP assert slow, texture reference count, path of texture handle. Oh, hang on a moment. This might be a legacy check. So presently when I go to bind to texture, I actually do a check to see whether it's already been bound. The reason for this is because we, when we go to bind a texture, we don't want to tell OpenGL to bind textures that we already have bound to a texture slot. So what we're actually doing is we are looking up the current slot of the texture if it's been bound, and then using that, and then binding it if it hasn't been. So for starters, I can confirm that the texture I got back out is 5, which is correct. 5 is the color texture handle, and 6 is the depth, from what I can tell. But I wonder if this call even makes sense now. Texture reference count. I think I'm going to need to implement this somehow. Texture reference count confirms whether the texture has been loaded. The idea is that if you go to load a texture from a PNG file, and then another part of your code loads the same PNG file, we don't need to bother loading that texture up again and then creating a new GL texture handle for it. So we actually normally use this to track whether the texture has already been loaded. What I'm doing here is I'm asserting that the texture reference count is greater than 0, because the idea is that if it is 0, then you haven't actually loaded it yet. But that's no longer true anymore, because now we're dealing with textures that are unrelated to PNG files. So what we'll need to do, instead of doing a texture reference count based on the file path, one way to handle this would be that I could extern texture reference count, and then in the Framebuffer file directly add references. But I'm thinking that the correct way to handle this would be to find a different way to assert that the texture actually exists. So on the next line, we've got current slot of texture.count, texture is not equal to 0. So actually, this test may be sufficient, because we take a look at current slot of texture. Because when we go to create the texture, we normally assign a value of -1. I guess the question is this available? Yeah, this is a member of graphics. So what I can do actually is I can get rid of the assertion that's failing. Technically speaking, it's not necessary. So that would be this guy. I can get rid of it because if I successfully created the texture, then I'm also checking to see whether the current slot of the texture exists, and this is done when you go to create. And because this is available globally, I can go into the Framebuffer creation down here, and then when I go to create the texture, gen texture, I can say current slot of texture texture equals -1. And what that'll do is it'll make it so that we can pass that assertion and move on. And so we'll assert that the texture actually does exist still, which is the purpose of the original assertion. So let's compile. Let's see what happens. Okay, so we're not crashing anymore, but we've got a problem. Graphics bind texture. Texture type does not match sampler type. btex. Okay, so actually that isn't accurate. We are dealing with GL texture 2D, which a sampler 2D and the shader code should be able to handle this fine. But what I have forgotten is to actually populate the texture tracking for this texture. This is winding up to be pretty complicated. I'm wondering if I'm wanting to continue down this path tonight because I got other things I want to do today. So in order to make this work correctly, we need to set up we need to ensure that when we do that test for the sampler uniform type against the type of the texture, we need to make sure that the texture stores that we store the sampler type required for the texture that we have handled in the frame buffers, which is a necessary check. It'll catch when we attempt to bind a texture to a uniform name that has got a incorrect GLSL sampler type. But it means we have to do additional work here. So here's where we got sampler type needed for texture. This needs to be set when we go to create the texture. Which right now means I've got to do an extern. That's not. I'm not a huge fan of using extern to externally link stuff, but in a case like this one, I think it's warranted because I don't want to do anything involving OpenGL code in my headers, because when I go to move on to DirectX and Metal, then that'll make it harder to make a portable API. So in order to keep that out of the headers, but still link against it, I'm just going to say extern, and then I'm just going to declare this again. Inside of the framebuffers.cpp. Not ideal, but probably the cleanest option I've got right now. Except for I don't want to do. I want to specify extern here, and then in textures.cpp, I would just make it not static. We'll say okay. So in Framebuffer.cpp, we've got a sampler type needed for texture now. And so when we go to create the texture, at the moment, it's always going to be GL texture 2D. In the future, I will need to be able to handle more types than that, but that's what we've got right now. So hopefully this will be enough to draw the frame buffer contents onto the screen. Apparently not. Texture type does not match sampler type. So there's still a problem. Let me go ahead and find that error message. Texture type does not match sampler type. Oops. Texture type does not match. Yeah. So that would be right here. I'm going to set a breakpoint. And take a look at the stack. So we're doing the draw sprite call. Sampler uniform types underneath the active shader name. Active shader options, uniform. So winding down into this tree. The one that begins with a 9. Shader options. So we use the batched version, and the uniform begins in 14. Okay. Yep. And 14. Okay, so the type that we're using is this guy, which 8B5E, which if we go to our if we go to the clad header, come on, here we go. So we're looking for OX8B5E. Yeah, so it's storing as GL sampler 2D, which seems correct. But if we go back to the place where we got the error, sampler needed for texture is 5. Okay, so there's a difference. I must have specified the wrong thing. Oh, I did. Okay. That's me being a buffoon. So what I did wrong was that I specified texture 2D instead of sampler 2D. They're separate. They are separate things. So where was I doing that? I was doing that in Framebuffer.cpp. Sampler type needed is not the texture, it is the sampler. All right. Hopefully that'll be the last rookie mistake I make, and it'll just start working because I want to do laundry and start cooking. Okay, still got a problem. It looks like the frame buffer is no longer an issue, but we're still not seeing anything on the screen. Let's head back to the dev state where we're using this. Begin batch, draw sprite, and batch. It's occurred to me that we might be using the simple MSDF shader still, which means that it might not be rendering with traditional colors. So what I'm going to do is I'm going to set the bind shader again. And graphics, set model matrix. I should also set to GLM mat of 4.1. Because we popped the camera, technically speaking, we still have to set the model matrix back to Unity. And we still got nothing. That's great. Alright, so I'm still missing something. How long have I been doing this? 2 hours. Alrighty, I'm back. I just had to wet my whistle, as it were. Talking is a thirsty business. But yeah, so at this point, I think I've resolved the most obvious bugs. But we're still seeing a problem when it comes to rendering the thing, which is that it don't render the thing. So I expect to see black prior to this code because we're rendering to an off-screen frame buffer. But at this point, I should be drawing a quad in the middle of the screen that should be filling the screen because we've popped the last camera, so now we're back in clip space. So the all of the coordinates should correlate. The -1 being the left side of your screen, 1 being on the right side of the screen, and so on and so forth. So that should be enough, you would think. I'm just gonna check my bases real quick. I'm gonna comment out the push and pop code for the frame buffer. And And just make sure that there's nothing weird going on with the scene itself, that the scene itself is still drawing. Yeah, so the scene itself, the drawing code still seems to be viable. The problem is down here. So there's a couple of different areas where this might be going wrong. For starters, there may be something wrong with the frame buffer creation and attachment process. So maybe the thing that we're rendering to is not correctly being updated with the graphics. I tend to think that's okay, but I'm going to quickly go through the tutorial we were following, make sure I haven't forgotten a crucial step. So we got gen frame buffers. Oops, I accidentally clicked on that ad. You never do that. GL gen frame buffers, GL bind frame buffer. That's been done. Oh, you know what? There's a check I have not done, which is GL check frame buffer status. So actually, I should perform this check to make sure that the frame buffer is complete. That would rule out problems with the frame buffer being at fault. So let's go back to frame buffers, and in the frame buffer create call down here, before we go to return, we need to check the frame buffer. So we go if db gl check frame buffer status equals, oh, you know what, that might be a problem. Yeah, let's put this, let me open this up again real quick. Code. Right, so the way that this works is that it'll just substitute the middle for code. But it appends a semicolon. Maybe that's all I need to do. Let me try that again. Hopefully I didn't just break something by putting this, taking the semicolon out. Here we go. If expected, oh yeah. So if GL check frame buffer status equals GL frame buffer complete. What's going on here? Expected a, yeah, I guess there's still a problem with, so I'm gonna need to leave that in there. What I'll do instead is I'll have to store this to a value. I have to do an old school an old school OpenGL error checking wrapper around my GL calls, because on Mac OS I can only do up to OpenGL 4.1, which means I don't have the new callback registration way of checking errors, which is starting to frustrate me a little bit. For now, what I'll do is I'll do EPGL check frame buffer status. I'll store it to a variable. And make sure that I'm using the right type, so it is a GL enum. Like so. So we'll say if that equals GL frame buffer complete, then we're good. Else, we've got a problem. EP error, graphics, frame buffer, and we will do complete and an EP debug break. And then what we'll do is we'll return 0 for a null frame buffer. All right, let's see whether that error triggers. If it doesn't, then the issue has to do with my quad rendering and not the frame buffer itself. Okay, so apparently the frame buffer is complete. EPD bug break is just a programmatic way of setting a breakpoint. Because it didn't throw a breakpoint and didn't display an error message in the console, I know that the frame buffer is ready to draw to. So that should be fine, in theory. Check frame buffer status. So we got bind and then delete. So GL and bind. I'm not seeing any steps that I've skipped in the tutorial, but I'm just doing it once over again, just to make sure that, yeah, this is a new territory for me, so I'm not sure that I would spot the problem. Yeah, so I'm not seeing a problem at all, honestly. So it seems like there must be something up with my renderer 2D, or maybe the way I'm setting it up that I'm forgetting. So let's take a look-see. So at this point, we've popped the camera. We've popped the last frame buffer. Why does pop frame buffer take a handle? It just occurred to me that that's weird. I don't need to I don't need to have in the handle here, I don't need to provide the handle to pop. I'm just popping the one that's on top. So for sure unrelated to the problem that we're dealing with, but oh my gosh. Wait, no, never mind. I thought I spotted a problem here with the ordering that I'm doing things, but it doesn't matter what order I push onto the internal stack and which one, because I'm still binding. Yeah, that's fine. Fuck. This is gonna drive me nuts. So let's head back to the dev state. Oh, was there an error? What error did I introduce? Oh, that, duh. But then heading back to the code, we pop the last frame buffer. Bind shader. I guess the first thing I'm going to do is I'm going to set the clear color. After we have popped the frame buffer, I'm going to set the clear color and clear the screen. Presently, I don't have my own API for this. I'm just directly using the OpenGL to do it. But if the problem has to do with the way that I am handling the texture, then I should see the screen fill up with a color still, and I don't. What if I change the scale on this guy to, let me change the scale on the quad to 0, make sure that it's not drawing to the screen. Okay, I still got black, so I've clearly got a problem. So if I've got no frame buffer drawn, okay, I know what I did wrong. Okay. So what's going wrong is that, and I totally glossed over the problem before. I had previously experienced a assertion when I tried to, or an exception when I tried to access the top element after popping the top. And I was thinking, oh, that's because I got the order wrong. That was kind of off the cuff decision that was actually totally wrong. I do need to pop the stack first because I need to get to the second to last element and bind that. But what I was neglecting to do was to do the check if fbstack.size is greater than 0, then I will do the bind the top. Otherwise, I need to tell it to bind the default frame buffer, which, yeah, I completely spaced on. So in this case, I would do else bind frame buffer 0. Why are you complaining at me? Expected a statement? But there's a statement. There's a statement right there. Whatever. So actually, I was just never going back to the default frame buffer, which explains why I wasn't seeing anything. Let's go back to the state, or to set the sprite back. Moment of truth time. Yes! There we go. So this is being rendered to an off-screen frame buffer, and then being rendered back to the screen as a quad, which, you know, it looks identical, but now I have a texture upon which I can do post-processing effects. So for starters, I'm going to reduce the scale to 1 for the quad that I'm rendering. And what this should do is you'll see that it's like I have a tiny little window in the middle that I'm actually controlling. So it's like once removed. And the reason why that's happening, let me clear this real quick. The reason why that's happening is because the frame buffer is accepting the draw calls for the entire scene. Oh, that's interesting. What did I mess up? I guess I still need to clear the screen for some reason. And what I'm doing right now is I'm just changing the clear color on the back to be black, so that way it's a little more clear what's happening. But yeah, so you can see like this window in here is exactly the thing that we are drawing to. It's just that now I'm telling it to render to a quad that's only half the size of the screen, and rendering there. I can also do other stuff, like if I was to set the scale back to 2, and then, like, let's say I wanted to do a like a pixel art game where I want it to look like the whole thing is pixelated. One way to do that would be to just literally render to a low resolution texture, and then sample that texture as a bigger one. And that's actually how games like Celeste work, where you get your pixel perfect gameplay because it's literally being rendered at the low resolution you're seeing. So I'm going to test that real quick. Where's the, oh, here it is. Push frame buffer, and then when I go to create frame buffer up here, instead of doing the 720p resolution that is the screen, let us have it. So this would be 640, and then this would be what's 360. I'm being really tired. And then this will be half the resolution of the window, and then I'm blowing it up to be the full resolution of the window. Does that work as I expected? Okay, we got something weird going on here. What is this? It's like rotating in weird ways when I do my movement. So there's something is wrong. I'm just not clear on what. In principle, at least, we've got frame buffers working, but now I need to know what's going on with this weird camera. It seems like setting up the frame buffer to do a lower resolution has led to some artifacts. What is happening here? So it seems like it's largely correct, but when I go to move the camera up and down, like this, Madeline is rotated like this. Maybe the problem is that it's like fish-eyeing or something, but that's not what I expected. It's like, I don't know, maybe it's not coming through like on the stream, but when I'm controlling it, if it's like I push up and it does like this instead of going up. So maybe there's something wrong with how I am rendering or sampling. What's the initial orientation look like? Okay, telling me a little bit about what's going wrong. It looks like I'm looking at the lower left quarter of the frame buffer. Which is not what I expected. So I created a frame buffer that's 640 by 360. I go to render to it. Oh, I think I know what the problem is. Let's take a look at the camera. Yeah, so when I go to create the camera perspective, I am making it, I'm basing the width. No, that's not the problem. I was basing the aspect ratio of the perspective from the Windows aspect ratio, but that actually should be an identical value to the lower resolution that I'm working at. So there's something else going on. What am I forgetting? The thing that's spooking me here is that I feel like I'm not forgetting anything. That's the thing that's messing me up a little bit right now. Because the code, if there's nothing wrong with the code that I am working in down here, then that suggests that there's something wrong with the internal workings of my rendering API somewhere. Something that I just didn't anticipate. Let's take a look at the draw sprite code. Make sure that I'm not taking any assumptions. So the renderer doesn't have any awareness of the window size. Out of curiosity, I'm going to adjust the scale of the UV sample bounds and see what that does. Interesting. So what I just did is I extended the sample bounds of the quad to be twice the size of the buffer. And we can see that it does cut off on the top right. Now, though now the motion feels more correct because now this is actually like centered. Like this represents the actual center of the camera now. It's just that the other 3/4 are not rendering. But this does show that there's not a failure to render. This isn't a failure to render to render the entire buffer. This corner is the entire buffer. It's just not, my rendering calls are not relative to the same origin or something. I suspect this might be a common OpenGL problem for newbies, so I'm just going to Google it. OpenGL Framebuffer off center. Yeah, so here's somebody else that looks like he's got a similar thing. Creating a custom frame buffer of 1920 by 1080, then mapping the texture of this frame to blah, 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 blah. You have to adjust the viewports to the new size when you switch between frame buffers with different sizes. Okay, yeah, so that's just a thing that I overlooked and I didn't realize was a thing. So when you go to change to another frame buffer, it's not automatically going to associate the lower left corner, the upper right. So let me go ahead and fix that now. Now that I've got a better idea of what's going wrong. So when I go to push or pop, I suppose I should probably do this automatically with the frame buffer stack. Let's go into this call. So in the push and pop frame buffer, immediately after calling GL bind frame buffer, we could just call GL viewport and then set the viewport there. The only reason why I hesitate to do that is that if you're in a practical example, if you're doing a frame buffer stack, you may actually want to immediately after that set a viewport that's actually like a subset of that buffer, in which case the automatic, you'd be fighting the automatic set to a specific size. So yeah, I'll have to do a JL viewport call in my API here soon, but just for the sake of getting this going, let me go ahead and just do it here. So for starters, when we go to push the frame buffer, we'll do ep GL viewport And then I forget the details for GL viewport because I rarely use it, or I have rarely used it. Here we go, GL viewport. It takes X, Y, width, and height. So it should be 0, 0, and then the width and height. And then the width in this case would be 1920 by 1080. Wait, that's not right. 1280 by 720. And that'll handle the setting the viewport correctly after when we're rendering to the. Actually, I would use this for rendering to the screen down here. I would actually need to set this to be the dimensions of the viewport, which is, what was it? It was half, so it was like 640 by 360. Like so. Okay, let's see what happens. I am still learning, but you know. Okay, all right. So now we're back to everything being full screen again. But the important distinction here is that now we are rendering at half the resolution and scaling it up. If we were to do this at 320 by 180, then we're having the resolution again. Oh, I need to actually change the size of the I need to change the size of the buffer again. Let me do that. .320 by 180. And now we'll be rendering at 1/4 the resolution of the actual window. And so now you're starting to see it's getting really kind of pixelated. It's a little hard to tell that it is actually pixelating with this many pixels. But there's some aliasing happening here on the edge, which is actually making me wonder. Oh, you know what? I think I might be fighting my own shader here. Let me open up the shader code. Because the shader I've been using up until this point actually featured pixel anti-aliasing. So for pixel art, we were anti-aliasing, but I don't want that anymore. Let's go back to here it is, simple material, and I'll just comment out all of this stuff, which handles anti-aliasing. And what we'll do is we'll just do final color equals texture, and we have a oh, why's my scroll wheel not working? Okay, that was weird. We have a btext macro for handling batchable textures. So we'll use that, wrap it around the sampler name, and then we just look up and report the final color. So let me run this again with that modification. All right, cool. And now we are looking at a much lower resolution. So you can see that now we've got jaggies all over the place. This is because, and let me switch to my gamepad real quick and do some smooth movement. You can see that we got this staircase effect moving across the screen as we pan the camera slowly. And that's because we aren't directly rendering to the screen anymore. We are rendering to this lower resolution and then blowing it up to fill the screen a little bit. And so this is actually how a lot of low resolution games work. A lot of low resolution games will do their actual rendering at a low res, and then they'll just blow it up and pixelate it. But you know, there's still a couple of issues that can arise because you kind of want things to look good still. You don't want to be doing all this flickering anti-aliasing stuff. So probably if I was to be working on this, Oh, let's take a look at what it looks like when we zoom all the way out. They're getting really distorted now. That's really cool. Probably if I was to do this in an actual game, what I would do is I would, instead of doing zooming in and out in the regular render, I would actually do zooming in and out upon the buffer render. So we render to the texture, and then when we go to render that texture, it's always the same resolution. We're not zooming in and out prior to rendering to the render buffer or the frame buffer, and instead we will zoom in and out on the frame buffer itself, and that would allow us to do nice anti-aliasing on the pixel art from a canvas perspective, and so we would avoid this crazy staircase effect. But this is one way that you might, pixelify a 3D model, for example. If you were in a game where you wanted to do a pixelation effect upon the 3D art assets that you're working with. Let's go even further. Let's go down to sorry, I got distracted for a second. Let's go down to 160 by 90. I just want to see. I'm just having a little bit of fun now. Yeah, look at that. Look at that. Look at how freaking low res that is. Man. That is crazy, crazy low res. Cool. So I think I'm pretty much done here. We've accomplished what we needed to do. Oh, that's interesting. Did I? Oh, I forgot to do. Yeah, this is gonna take some getting used to. I forgot to actually change the viewport. So it was doing that lower left corner rendering thing again. There we go. Yeah, so the camera perspective is better. Yeah, so there's still quite a bit of little cleanup work to do for the API that I'm working on, but in principle, we've got the render buffer API working, which means that I can render to a texture off screen and then do stuff to the texture, and then render that. So yeah, I think I'm done here. I'm gonna go ahead and close out the stream. Thanks for the look, Nobi, and thanks for Making Zora for your follow, and Nobi for following me, because that's cool. It's cool to have followers. I probably won't be back on stream for a while, because this was the last big hurdle. This is the last big hurdle prior to my next big task, which the next task is going to be to develop an editor so I can start constructing scene files from a GUI. And that's going to require quite a bit of design work that I haven't done yet, because I'm going to have to re-architect a couple of fundamental things. I'm going to need to figure out, for example, exactly what it means to build the editor, because I want to do modular everything for the most part. I want to be able to have a game developer very easily just create their own system and their own component types to plug into the game, which means that the editor has to have a high level of customizability. But at the same time, do I actually want the editor to be game specific? Because like if all I do is make an editor like a version of a build of a game, then you can't distribute the editor very easily, at least. You have to compile from source every time you want to make the editor, which might not be a bad way of going about things, but maybe I want to do something different, like support dynamic linking. So I have the editor be its own standalone application, and then it just like accepts a DLL containing the code from your game. and then it loads up the systems and stuff that you implemented for your game so you can work with them in the editor. And for that matter, what about scripting? What about hot reloading? Like if you're writing a script component for some entity, you know, you don't want to be like having to recompile and relaunch your editor every time. So you know you kind of gotta have a form of dynamic linking there in some fashion, so that you don't have to reload the entire editor just because you made a tweak to how your camera controller works, right? That's going to require a lot of thought. So I suspect it'll probably be on the order of like a week or two before I'm back to work on stream. I'll be doing some development work on the back end. But yeah, I'll have to do some laundry and do some cooking. Have a happy Thanksgiving for the folks in the States. Talk to you later.